don't put down the things that aren't there. And you use P, M, and T in the quantity present to tell me whether you think it's principal, medium, or trace. The next column over, let's see, it says quantity found, that's what you think it is. Quantity present is the third little column, that's for me to use for grading. Okay. Once you have done the analysis, you turn in your card and you can discard. Goes in the waste bottle, except the test for mercury 1 and the test for silver ion. And if you didn't get, if I said that doesn't look like much of anything when I looked at your precipitates, or I said there's a hint of something there, don't bother saving that. Now when you discard things, where do you put them? Since these are all metals and things, they go into my waste bottles on the back side of the splash pan. Okay. Now to save things, you probably don't want to save them in your good test tube. I have lots of old test tubes up here for saving things. Because we'll have about 26 ions. If you're saving 26 confirmatory tests, by the end of the semester you won't have any good test tubes to do your experiments in. The way you transfer from one test tube to another, you get it in suspension, and then you transfer it. You can centrifuge into the second test tube where you're going to store it. You centrifuge that second test tube, decant back into the first one, stir it up some more, and you do that multiple times until all the precipitates transferred from the first tube into the second tube. And a lot of you had precipitates for your references that were smeared all over the place. The way to avoid that is you stir everything up, get it in suspension, and centrifuge it. Doesn't centrifuge out properly, you do it a second time, stirring it up and centrifuging again. Usually if it starts depositing all over your test tube, it means you have a sticky, dirty test tube. And when the precipitate is in several different spots and up the side of the test tube, it doesn't make a very good reference. What you're using is these are references for when you get to experiment 5. Ultimately, you'll be doing all the procedures, except the reason we don't store the lead precipitates, we never do procedure 3 again. After we finish experiment 1, the next time we look for lead, it's going to be part of group 2. We'll always make sure it enters into group 2. How do we do that? We'll always add the extra water. That keeps the lead from precipitating. It stays in solution with the extra water, and now we'll carry into the analytical group 2. Questions about that? Okay, then we started discussing experiment 2. Somebody said, how many days for experiment 2? That's all answered on this column, or this sheet here. It says we're doing 2 periods for experiment 1. One of the days you did your known, the next day you did your unknown. We're doing 6, but don't forget we're dividing some of that time up with the kinetics experiment. So some of you will be doing kinetics experiment, others will be doing the experiment 2, and then people that get on the spectrophotometer that didn't do it will do that while the other people go back to begin 1, 2. Okay. Because there's a lot more to do for experiment 2. And notice experiment 2, I was really generous for experiment 1. I gave you 20 points. These are 45, 45. The unknown is, the general unknown is 50 points. Okay, so that's some discussion there of how we relate back to that. This just gives you some notes about principal, medium, trace, and how I grade them. Then, the next thing, we're doing that formula you're calculating drops. Hopefully you did all of that at home already. First of all, the people that didn't finish experiment 1 will continue and finish experiment 1, get their unknown, take the quiz. Somebody, I forget what happened, they didn't take the quiz, so they'll take it today, and they'll just have to come up and see me about that. I didn't get my timer fixed, so you're going to have to trust that I'm looking at my watch correctly. That's all. It's 3 minutes. The reason I bought the timer is people didn't believe me when I said, oh, my watch says 3 minutes are up. But I'm not gonna, I'd probably, for the first one I gave everybody several extra minutes, so I was fooling around with the timer. But not much. And in the future, I think I just need a battery. I forgot to keep it on. Coming back to this, calculate drops for unknown. I already said this. Just put a condition. And then you want to add the drops directly to your casserole. You're rounding up unless it's really close to the whole number. You always round up for your drops. That's the biggest problem the first time through is people tend to lose some of the material, so if you round it up, you'll have a little bit more. That should look more like what it actually look like. Okay. Put everything into your clean casserole. And I told you about cleaning with aqua regia if necessary. Most of the time, if it looks clean, you just rinse it with distilled water, and it is clean. Sometimes though you have black deposits and stains that just don't want to come out of your casserole. Then you use the aqua regia mixture. The mixture of concentrated HCl and nitric acid is referred to as aqua regia. Came from the fact that in the old days, this was one of the reagents that dissolved gold. Gold was the metal of kings, so it was older kings, I guess, except it became granted. Okay, so that's the material, that's what you're using to clean the casserole when nothing else works. Most of the time, though, it should rinse out. And the other thing I emphasize, once you've mixed up your known in the casserole, it says take 4 or 5 drops. In the procedure, you want to use everything in the casserole. And you're starting off with 5A. What was the most important thing I told you when you're doing 5A?
Don't bake.
Don't bake it. Doesn't want to turn brown. Okay. 5, 14. In other words, you're using everything, all the drops you've got. And 5A, as I said, the primary purpose is to remove the nitrates so you don't get much sulfur. Then you're going along and you're putting in, I said 12 molar works just as well, and you have to do it fewer times. You put in 5 or 6 drops of the acid, HCl, evaporate down to 1 or 2 drops. You put in 5 or 6 drops of acid, down to 1 or 2 drops. You do that several times without baking. I said 3 to 4 times. There's no magic number. I pointed out you can look at the size of your crystals, the color. When you have copper, at least, of the copper crystals, the other thing is mostly white sort of material. So you look at that, you keep doing it until you get tired. Evaporate, I'll write it again. It's so important. Okay. The last time you evaporate, you finish up over the boiling water bath till it's dry. So I'll just say use boiling water bath. Because now you want to control the pH carefully. We're going to 5C, we skipped 5B, that's just the hydrogen sulfide generator method. Have a hydrogen sulfide generator. We're using thiocetamide. Your first thing it starts off saying 4 drops of 2 molar HCl. It doesn't look like it's quite 4 drops. You can use an extra drop of HCl. And I said, save the casserole, because later on the procedure asks you to add water. I'm not going to write all these steps down, I wrote them the other day. But save the casserole, and when the procedure says add 8 drops of hot water, you do 4 drop rinsings of your casserole into the test tube. Thiosediment decomposes when you heat to give you H2S, characteristic odor of rotten eggs. Now, one of the things I notice a lot of people are in the habit of having the openings on the hood all the way open. You should never go really beyond halfway for those openings, because it reduces the efficiency of our pumping system or our exhaust system, and you don't get as many fumes leaving the laboratory as you would like. And when you're doing this, you may only want to have with the opening about a foot or so and reach underneath to work with your material to try to keep all the H2S out of the lab. The other thing, after you take something out of one of these test tubes out of the boiling water bath, leave it sit in your test tube rack in the hood for about 1 or 2 minutes till it cools off, so you're not bringing H2S out into the laboratory. You take your test tube rack, your test tube out of the hood, and you start smelling rotten eggs, put it right back in the hood, and don't walk through the lab saying, boy, this lab really smells bad here. Okay? You want to keep the fumes out of the lab. We want to share it with the rest of the campus community, or something. Actually, we don't generate that much, but compared to some of the refineries over here, they produce a lot more H2S. Or apparently, you read the paper in the Salton Sea, they're having all the fish die off, and the fumes of H2S are reaching all the way into southern Orange County from the H2S that's coming out of the water there, decaying vegetation. Okay, so you're cooling in the hood, then centrifuge. And you're checking for completeness. What it says to do is, and he has you do about 20 test tubes, and then at the end he wants you to combine all the precipitates, and I suggested that what you do is you centrifuge, decant into a clean test tube, save your precipitate, check this supernatant liquid, and he says let it stand for a few minutes, and I said you always put it in the boiling water bath, because the thiosediment decomposes more efficiently in the boiling water bath. Okay? And again, when you don't make any more precipitate, you will have, oh, I forgot one step here. If you make some more precipitate, after you've done that check for completeness, what you do is get everything in suspension. Transfer it back into your original test tube with precipitate. Centrifuge that test tube, decant into your semi-clean test tube, and check again with more thiosediment, more heating. And sometimes it takes 1 or 2, possibly even 3 treatments with thiosediment to get complete precipitation, especially if one of your unknowns contains a principle or something. It takes more H2S, longer time to get the complete precipitation. So finally you'll end up with your precipitate all in one test tube, your decantate in the other test tube. And I'm going to the notes here, see here somewhere, because I want to unconfuse you here. Now, right here on the bottom of page 178, bottom of the second paragraph or so, it says when the test shows that the precipitation is complete. In other words, you've added thiosediment, you've heated it, you get either no more precipitate or a very small amount of precipitate. That's essentially complete. Now, this is the part that's confusing. It says add some water, 2 drops of hot water, 2 more